There we go. Perfect. Prototyping in innovation. So the first thing I want to talk about is the basic question that I don't think is asked enough is, why do we prototype? So prototyping is done for several reasons. The first one is to explore, to build models and find ways to explore ideas and develop them further. The next one is to collaborate. One of the things we do when we have ideas is they're internal representations in our heads, and it's sometimes very difficult for us to be able to explain those. So building prototypes is a way for us to share our ideas with others. And I'll show you some examples of how collaboration is enabled through prototypes. Generating ideas. One of the things we can do with a prototype is interact with it. We can also combine and modify it on the fly, and this allows us to generate new ideas. And then finally, and this I think historically was one of the main reasons in innovation people did prototyping, is to test, to understand whether the insights and the values that you think you've created with your ideas really come to fruition. More importantly, I think what testing does is it teaches a lot of what we didn't know or didn't understand well. So what you need to do is start with the goal in mind. And I think this is one of the biggest places that people make a mistake when they look at prototyping, is they think about it as a doing rather than what the outcome is. And the outcome of prototyping is a very important one. And it's really all about improving and increasing the number of ideas. And this is key, because what we do is just to improve and increase ideas. It is not about creating something. And I think this is one of the biggest misconceptions, is that we're building prototypes so we have something, an object or something. That's not. We're building prototypes to improve and increase our ideas. And that's what we want to focus on. And that'll help guide you in what you do for prototyping and what you consider a success from prototyping. So let's start looking at exploring. So the goal is to develop an idea further. What does the idea in your head look like? You know it, but other people don't. What are the features? What are the functions? How does it work? This is something that I think you probably in your mind have some idea, but it's not until you start to build one or prototype it. And I should just pause here. When I say build, it's not that we're actually physically always building something. We're creating something, but it may not be a physical 3D object. It may be a sketch. It may be a PowerPoint deck. There's lots of different ways we'll look at it. What does it look like? And here's a great example. This is from one of my creativity workshops. We were doing a classic example of building a purse or a bag for an individual. And what this person did is, they using papers and just some kind of standard stationery materials, built together a bag, and then she started seeing what could go in it, how it should look like, and she was able to explore her ideas by building. Here's another example where instead of building something physically, we can prototype it in a virtual way. So this is a 3D rendering of strawberries in a bowl. This was for a product development, looking at what products might look like, and it involved some strawberries, and they wanted to see what different colors would look like, and they could play with lighting. But once again, it was just a way for them to start to realize and explore the ideas they had in their head. The final one, because we talk a lot about prototyping and design thinking related to products that we use as people, the exploration is actually something that scientists use quite a bit in building models. And I think one of the most famous one, if you can't recognize it here, this is the model for DNA, the double helix that James Watson and Crick invented. Key to their success, in fact, their entire success of their approach to innovation and what they won the Nobel Prize for, was that they were model builders. They looked to build a model, and in building a model, if you look on the right, as they were putting it together, there was a key step where they actually took two pieces of metal and cut them out to be the same shapes as the molecules would be, and to see what kind of combinations they could come together. And they found the key combination by playing around with these pieces of metal in the lab as building the model, and that's what led to the discovery of DNA, the structure of DNA. So this all went through the prototyping through model building. So it's not just for consumer products or services, it's for scientists, engineers, for everyone. Collaborate. Collaboration, I think, is a key part that comes out of model building, our prototype building. The goal is to express ideas for others to understand. So you want an external representation of your ideas. You want it in a form that others can interact with. And this is important because sometimes we might create a prototype in a form that's useful for us, but may not be useful for others to interact with. In a medium you both understand. If I were an engineer and I was building a complex model like I just showed you of the DNA, and I met somebody who knows nothing about chemistry, it wouldn't be something they could really interact with. So I'd have to find a different way for us to build. So engineers might use simulations, artists might use canvas, sculpture, and then salesperson might use a diagram or a PowerPoint. And I'll show you a little bit later on, you can actually do a lot of prototyping in PowerPoint. And the reason is it shows images and it also has the ability to show a sequence, particularly in time, and that allows you to create several different representations of ideas. And so here's an example from one of my creativity sessions. And this is a, you can just see here as they go, these are people working around a remote control car, and they're modifying it for the purpose of a design challenge. And what you can see as we go through this is that these people are working hard in order to be able to collaborate. So what one's doing is he's placing a part on the car, and then he's asking what others think, how it fits. They're able to talk about it. They have this representation amongst them that allows them to go through and learn together and generate new ideas. The next one is to generate ideas. So the goal here is to create new ideas. So play is key. This is one of the things that when we talk about innovation, we see a lot of people talking about being carefree, putting aside constraints, playing. Well, this comes in prototyping because what you want to do is you want to create something that you can play with. And in the playing portion, and by the way, why do we say play? Because if we build something that has a specific purpose and we use it only for that purpose, then we're really not learning anything. The idea of play is that we're using it for different purposes. We're trying different things with it, maybe random things. And we're just trying to, if you will, have some fun. But really the fun part is that we're not necessarily using it in exactly the way it was intended. And that allows us to learn and see new ideas. We want to seek to combine, to connect, and to remove parts of your prototype. We want to work with others in the process. That'll help us find new ideas. We want new ideas that come from the activity and the combination. So once again, it's sort of like we learned in an earlier lecture, we don't have ideas, we have to find them. And one of the ways we do in prototyping is by collaborating and interacting with that prototype. You will see new ideas as they appear. And that's one of the reasons we've seen before that oftentimes once the idea is right in front of us, then we can see it. But it's not until we've moved a lever or we've put a Post-it on something or we've drawn something on the screen are we able to see the real impact of those ideas. And so here's an example that I'd like to share with you. This is a game, and I do realize this plays a little bit fuzzy for you guys. But basically what we did is we were prototyping new types of games. And what they did is they found that just talking about it and drawing sketches really didn't give them any new ideas. What they started to do was to play the game. And if you notice on the side, you'll notice that there are these long rubber bands. And one of the things they did is they were putting this together and they were chatting amongst themselves, is one said, hey, we need something that can capture the ball. And somebody said, okay, we'll just put some cardboard around the table. And somebody said, we want something that's more interactive, that the ball could bounce off of. And they had this long discussion that finally led to these rubber bands. And that was one of the key aspects that made this game work, was the ball would bounce off the edges. And this happened from building and trying. The ideas came about one after the other from this prototype. Testing. So the goal is to learn about the value proposition. So we're not trying to see if it works, we're trying to see if the value you're trying to create is valid. And I should just separate that. In product development, we build something that maybe has a function and we want to test, does that function work? In innovation, we're trying to see, does what we built or the idea we have the value or the insight that we thought it does. Because often, if you remember, insight is about understanding value not said by the user. And so how do we know whether we've really captured that if they haven't articulated it? Well, one way is to build a prototype, give them the prototype and see if it works for them. So does it work? Function the way you want? Do people like it? Why do they like it? That's important to understand, whether it just happened to be that they liked it and it was based upon your ideas, or maybe there was different ideas that they liked it for. What could you change or make it better? That's one of the important parts about prototyping, is this iteration and generating new ideas. What do they think, feel, or need that they didn't say? Once again, we go back to empathy, and you have to observe when people are dealing with the prototypes to understand what they want. Testing is not a one and done. You should be prepared to iterate on the spot and learn. If you recall from the case study we did with Cineplanet on design thinking, they actually had somebody printing posters up in the office, and they put the posters down in the cinema lobby that would maybe show some movies or explain certain aspects of how to buy a ticket. And they'd see people interact with it, and they'd find a problem or have an idea, and then they would print another one, run downstairs, and put it right over that. So within 30 or minutes or an hour, they were able to change those as we go. And that's the kind of testing and iterations that we want to have. And so here's an example of, once again, this was from a workshop on creating games. And I should just mention, the reason why in my workshops we build games is because games are supposed to be fun. And what is fun? And that is something that's very, I think, user specific and also not very well articulated. And it's really an analogy for finding these unmet needs and unspoken needs that people have. Finding something that's fun, it's very difficult for somebody to tell you in advance, but once they see it, they know. And that's why we do games as an example, for you to try to articulate what's fun. And then when you build it, you'll start to see how you can really find out, does it really meet what the user's looking for? And so here was a basic test of such a game for a prototype. Here's another one. This is one we'll do a couple times. This was popular on the internet. This was a remote that was created for grandma. There's a couple renditions of these out there on the internet, but the basic idea is they covered everything that grandma didn't need to do. They put reminders on the remote for what grandma needed to know, and then they just gave it to her to see, is this something that grandma can work with? And for those of you that use complex remotes, we'd all appreciate this simplicity if we could get it in our remotes. Another way to test is to actually build something and interact. We saw some physical prototypes. Here's something some students in my class did for an external company. They were working on a project with Ferrari. And what they did is they went and built a virtual version of a phone app on a platform called Figma that's set out to do this. And this allowed them to kind of build an actual app, and then people could go in and click around and test on it. So the testing doesn't have to be with a physical, but the key is there has to be some form of interaction is what we're looking for, and then getting feedback from the people that are there. Finally, I think the key thing for all of this is to have fun. This was at the end of one of my workshops in Australia. We were playing with Lego, and they just wanted to see how high they could build a tower of Lego people. And this was the winning tower, just for fun. So that's the why of prototype. Let's talk about the how of prototyping. So rule number one, KISS, keep it simple, but not stupid. And so I think sometimes we think if we simplify things that we make them maybe not as important or not as valuable. But as you saw in that remote for grandma, that was pretty simple, but very effective to see what keys grandma needed. And that's really what we want to do. We want to keep it as simple as possible, because the complexity does two things. One, it wastes our time and money because we have to build something complex, and that takes a while. And the goal of this prototyping is to learn quickly. And then also, it also covers up, I think, some of the basic pieces of what is of value. And we'll see some examples of that in a second. Minimum viable prototype. So we want to build the absolute minimum that we need to test our idea. And this was a great example here was, are these the buttons grandma needs? And guess what? If you give this to grandma, she's going to tell you really quick if these are all the buttons she needed, and also tell you if she understands the new labels that you've put down. Rule number three, it should be a user-centered prototype. The prototype is meant to be interacted with. Ensure that it's in a media that users can use. So for example, grandma could use that remote. If you gave her a remote that was on a phone app, she may not understand how to use that and be able to use that. You shouldn't have to teach someone how to use your prototype. So if you're trying to show somebody how to use your prototype, you failed starting off. They should understand how to do it. Now, of course, there are some exceptions, but the point is that if your prototype doesn't resonate with the person, they don't know how to use it, then it's very hard for them to interact with it in a natural way. And it should be intuitive, as we just mentioned. And it should be in a form they already understand. So for instance, if you gave myself a phone app, I'd already understand that and I'd love to use it. If you gave someone of a younger generation, maybe a new digital tool they might be very comfortable with, it wouldn't be an issue, whereas somebody who didn't have the experience or the availability of the tools may not. The best prototype is the quickest. The goal is to get new insight or ideas as quickly as possible, period. So you want to make it as easy and as quick. I don't say cheap because the goal isn't necessarily to save money. The goal is to get the quickest prototype. And often that means we're not going to spend the money to make formal manufacturing or fabrication processes. We're just going to do something quick and dirty. And that's why you see everybody building with Post-it notes and pencils and Play-Doh and everything, because it's really easy to do something quick. The quality of your prototype is measured in the speed and number of ideas it generates, not in how it looks. That remote's a great example. It might have taken them 5 minutes to put together and they got their answer right away. In the Cineplanet design case study, where Cineplanet was the theaters in Peru, putting up a new sign, they were able to get feedback and iterate within 30 minutes or an hour. The prototype should match the skill of the person. So once again, let's just use the example of a sign that Cineplanet used. It should be something that everybody from kids to adults can come in and read and understand what they need to do. Rule number 5, balance flexibility with ease of use. Now, I've got this picture here, and you've seen I've used a lot of Lego and I've used a lot of Play-Doh. And it's very interesting because one of the benefits of Play-Doh as a method for prototyping is that it has no form. You can make it anything you want. So people like it because they can roll it in balls, they can make snakes, they can do a lot of things. The downside is it has no form. So you're not able to create things that have complex structures very easily unless you're very talented. So what I find is particularly people who aren't used to working with Play-Doh have a great deal of difficulty building anything but a worm or a pancake from Play-Doh. Lego, on the other hand, one of the things that Lego does is the bricks are clean, they assemble easily, they don't require any skill or dexterity by the person. And so people are able to build rather complex building structures, tools out of Lego because they already have that rigidity or form fit in. The problem, the downside is if you can't imagine what it looks like with Lego, then it's very hard to build. And so this is just a good lesson, is to understand that there are some materials like tape that can be used everywhere, but in the end, it won't build you necessarily a very complex prototype. And there's other things like 3D printing, Lego, advanced CAD tools that can build very complex ones, but may not have the flexibility that you want. So balance those back and forth. So what I want to do next is a case study on Target's Good and Gather. So this is a real case study that a colleague of mine, Shuya Gong, worked on this and shared this with me. Sorry, wrong slide. There we go. So Target, a while back, was looking to generate a new brand. And this is a press release of them unveiling their new brand, which is Good and Gather, the new flagship-owned brand of Target. It's about great tasting and affordable food and beverage products. So this is the end. We want to go back and figure out where it all started. So here's a picture of their products, Good and Gather. And if you've been in a Target, this is a popular, it's a cross between a supermarket and a department store in the US. It's one of the very large superstores like Walmart, if you're familiar with Walmart. And so these are the brands that came out here. And so we want to say, where did this all start? And I think this is an important lesson in understanding how prototyping and ideas work. So it started with a collaboration between Target, MIT's Media Lab, and IDEO, who we've heard of before, CoLab. So I just want to explain a little bit. So MIT's Media Lab is basically the design school. So the design school that might design a chair or a mouse or a keyboard, integrating with technology. So the Media Lab is the intersection of technology and design. IDEO's CoLab is about working with real companies in their space on specific problems those companies want to work on. And obviously Target was the retailer here. And what I'd like to do is I'd like to start with a short video that they shared on this co-creation on what they called a circular food economy. So this is one of the ideas about understanding how food fits within our ecosystem. And to facilitate better viewing, I will go ahead and play this now. Please put in the chat if you have any issues with viewing this.
Why are we here and what are we doing? That has been a journey throughout the days where every now and then you ask yourself that question.
It has been an extraordinary week. We have all of these extraordinary member companies that are here really looking at how we can be re-envisioning.
Just fixing this setting here for you, just a moment. And I'll restart that.
Why are we here and what are we doing? That has been a journey throughout the days where every now and then you ask yourself that question.
It has been an extraordinary week. We have all of these extraordinary member companies that are here really looking at how we can be re-envisioning the food system and applying circular principles to a regenerative future.
We're here to take a very
you can notice they're starting to
audacious,
prototype
but also
here
very
as they work through these.
Concept of circular economy. We're trying to take that to the next level and actually make it much more tangible and concrete.
Circularity is so closely linked with innovation, and it's innovation that's
here's
the
them
path
sharing
forward for
ideas
us
as part
as
of their
we
initial ideation
face
session.
really daunting challenges in every aspect of our economy.
The huge light bulb was the build something, build a prototype. It generates so much more positive feedback than just an idea which generally gets crushed or naysayed.
Traditionally,
some initial prototypes
talking is so much easier. It's easier to sit around the table, and we found ourselves doing that at several points. And so breaking out of that and actually starting to build was kind of a revelatory moment for all of us.
The experience has been really intense and really energizing, and I think really eye-opening. And it sounds a bit like a cliche maybe to say that, but I think that the fact that so many of us spend a lot of our time thinking through these systemic problems, but we do so in our own companies or in our own organizations. And I think the beauty of this is that we're coming together with different companies, different participants, different skill sets to together co-create basically a solution. I think there are very few and special opportunities that you can have to do that.
And so that's what's really most exciting for me, is to be able to work with, potential competitors in this space. And instead of competitors, it's peers. And that shift has really been kind of foundational for me.
So that was a great example of co-creation and also some of the steps in ideation and also prototyping. And so their approach was to go out and to look at solving some of the problems they saw with food. And one of the basic ideas they had early on was very simple. And it was put what's inside on the outside. And what they noticed is as they looked at products, that the products had a label on the back that told them what was inside, but from the front, it was always just a picture or an ad or a slogan or something. And so they had the simple idea is, could we simply put what's, excuse me, what's inside on the outside? And so they started with just printing out a sheet of paper and sticking it in front of the package to say, here's what we have. That was a prototype. They next went to getting everything and putting it in clear bags and then putting labels. So you saw the initial prototype was just a piece of paper in front of the package. Now they're going to put a label on top of the package. And you can notice they're starting to label each an individual one of what's inside. The next step after doing that was to actually build some containers with those labels embedded on them. This is actually a little bit beyond the prototyping stage because all we're doing here is we're making it look more professional, but they felt they needed to do this because they were actually selling these products at a store. So they wanted to do testing with people in a store. And so they did need a package that had a good enough quality where they could actually sell it. Whereas the example we just saw on the previous slide, these weren't something they could actually sell in a store. It was something they could only interact with users. And from here, they went on and they created their product, Good and Gather. And if you look here on the lower left, if you look closely, it tells you these are blue corn with flaxseed tortilla chips. They're gluten-free, no preservatives, and there's a few other pieces of information on that. So you can look at the front of this and immediately understand what's in it. And this was a big success because people now felt that they could understand what they're buying because what was inside was made in the front. And so this is a great example of how they use prototyping to get the basic idea from the initial sheet of paper in front of the bag all the way through to the final prototype. And if you go to Target today, this is their entire line of products from Good and Gather inside of the stores. So let's talk about prototyping tools and approaches. So the first thing is use what is around you. Here's an example from my daughter's desk, and I just went in and took a picture. We've got some Post-it, a stapler, a pencil, a plastic bag. We don't need to go out and necessarily buy or create anything. Sometimes people want to offer some more advanced tools, and that's great, but you really should get the idea that you should build from whatever's around you. You shouldn't think, I have to go get something to prototype. You can just do with what you have. You don't need special tools or materials. So here's a great example of prototyping the game. This is just colored paper, some markers. They drew some things up. They used some Play-Doh and some pieces from what they found around the room. Okay, it doesn't have to be complex. Okay, so here is a shower enclosure with a towel drawing on it. Seems like a great idea. But the problem is that the husband leaves the towel on the shower. Now you can guess that I'm the offender here. And so my wife looked for a solution for how could she overcome this. And she decided that she was going to try to prototype a simple solution. So the possible solution, she thought, was just to find an easy reminder for me not to do that. So what she did is she went into our daughter, had some old bath toys that she used to play with as when she was a toddler. And she pulled out a little, I think this is some kind of sea creature in a shell. And she just put it on top of the shower. And that was it. And so every time you go into the shower and you look at the top, you see this little creature looking down at you. That creature has been on our shower now for 4 years. And it turns out the prototype turned into the instant product. But why I use this example was it was just taking something in the room and just moving it over to test the idea, and it worked brilliantly. And that's all we need to do for a prototype. We just need to figure out, like we saw in the example of the remote, maybe we take a Post-it and we cover up a button. It can really, really be simple. It doesn't have to be complex. So here's some methods for prototyping. One is to just draw it. Sketching out's a great way to start. Just build it. Build an example with everyday materials you have around. One of the things that I find is very effective is if you give people just a few materials beyond what they normally have. So when we do our workshops, we may have a few toys, maybe a few other items in the room, and we let them use all of those. And then we use connector materials like tape, paper, Play-Doh, things that can help build a bridge between, for instance, a can they find in the room, or a whiteboard or a chair, and the idea that they want to do. Strings, another one. So if you can get a few materials that allow them to connect things already around them, it's a way to enhance that. You could just print it. Obviously, 3D printing has become very popular. I want to let you know, you can go to the internet right now. You can download a 3D printer file and upload it to a company called Shapeways. and they'll 3D print whatever you want in whatever material and send it back to you. I get all kinds of toys that I find online that I think are cool and have them printed, and they ship it to your door. So you don't have to be an expert to do this. You can just get the files and upload them, and it works. You can design it. So I showed you Figma before, this app, this high-tech version, but once again, it doesn't need to be high-tech. Here's another version where the person just put Post-it notes and little labels on top of the phone app. This works perfectly well. As long as you can test the idea that you want, that's what you need to do. The next one is PowerPoint it. Now, this seems silly, but PowerPoint is actually a really great resource for you to be able to show images, for you to be able to show process steps, and for you to be able to show animation in time or a sequence. So you could build, for instance, a new website by showing the different images. And if you're not familiar with PowerPoint, you can actually put on some of the items on the screen. If they click it, it will take them to the next scene. So you can actually have it move around the PowerPoint by clicking on different things. You can have time sequence by having animations. This is really great for people who want to develop processes. Like, for instance, let's say you were working in an office and you wanted to prototype the flow of a purchasing form that came in. You could go through and take pictures and show each step of the process here, and you could storyboard it. And people could look at the flow and you could rearrange the slides. So it really is a robust way to do things like services, processes, and digital interfaces. You can be an artist. I don't know if you recall from one of our earlier lectures, but Adobe's entire idea, their insight, was that anyone could be an artist. And Adobe has created a suite of products, Photoshop, Illustrator, Dimension, just to name a few, and Audition is another one. And you may think to yourself, why do they have all of these different softwares? Where the goal of each software is for the average person to be able to create a professional looking product. And each software package basically is tailored to a specific product that a person might want to make. And so what's great about Adobe is you can buy a subscription, you get access to all of them, but it really is a way for you to create things. I create professional looking magazines. I create 3D renderings of objects here. I use Adobe Premiere to do videos. So it really can be a way for the average person who's a little bit interested in tech to be able to create professional items. And then method 7 here, make a model, just bringing you back to, it's not all about remotes and toys. It can be about really advanced scientific or complex thoughts like we did here with this model for the DNA. Now I'd like to return to a favorite here, the IDEO shopping cart case. But what we're going to do is we're going to watch a longer version, the full length version. We're not going to watch it all. We're going to go to minute 1540 at this YouTube link. And we're going to watch and see how they prototype. And some of the things that I want you to look at is how they develop their ideas in a number of different prototypes, and then they discuss how those work, leading up to the final prototype that they show at minute 1742. And I just leave this here in case you want to connect on this video later. We'll go ahead and switch over now and watch that video.
Maybe looking at the workplace of the future here.
It's one thing to be able to do a product once in a while, but if you can build a culture and a process where you routinely come up with great ideas, that's what the companies really want.
Okay, Peter, we're done.
Back at the shop, it is 6 o'clock, and the 4 mock-ups are ready for showing.
Notice how they've mocked up these prototypes. He's using baskets. If you notice this black container here is something you can buy from Home
hand
Depot.
baskets onto.
And he's just using the things they had around
gets you through the traffic jam at
test out
checkout.
these ideas.
That you could mount a scanner.
He made a few
on the
things out of that
shopping
white
cart, so
plastic.
You, as the customer, as you pull it off the shelf, would scan each item.
One that's built around child safety, and another that lets shoppers talk to the supermarket staff remotely.
Yeah, where can I find the yogurt?
But the adults, again, decide more work needs to be done before the mock-ups can be combined into one last prototype.
Why don't we have all the carts come up here for a second?
I think you take a piece of each one of these ideas and kind of back it off a little bit and then put it in the design.
The design is still not there. But there's another motto at IDEO, fail often in order to succeed sooner. And some of the team will be up half the night trying to put together a design that finally does work.
So
And I'll just continue us on, so if we can remember
It
what the
is
final
day
prototype
5.
looked like.
and day-
Here we go. Here's some of
The
the
cart,
making
which
they
is
have.
designed to cost about the same as
And there's
today's
the final
carts, is
prototype that
different
they
in
came up
every other way.
So that's just a great example of the process for prototyping. And you can see how they created several different prototypes. They investigated it. I really liked how they used objects from around the shop. And they did fabricate a few things. And I think that's one of the things that maybe is useful takeaway for all of us is having the ability to modify what we have currently around us helps us because that lets us create new combinations of things. So just a final comment on the prototyping process. So the process is not a single step, but it's a continuous cycle of conceiving an idea, creating a prototype, learning from our interaction with that prototype as quickly as we can, refining those ideas, conceiving a new prototype, and moving again forward. The best prototypes are one that we can modify instantly as we get new ideas. It's very inefficient for you to develop a prototype and share it, and then come back and have to rebuild it, share it again, go back to the lab. What you want to be able to do is modify those prototypes directly in where you're testing so that you can see if your new ideas are correct, and that helps you find some of the best ideas. Now, I think one of the things that's important here is great ideas are somewhere out there, and there's a path between your ideas now and those great ideas. And that path may have 5 steps, may have 20 steps, may have 100 steps. Really, the key in innovation is how do we accelerate moving between each one of those steps? And prototyping is a great way for us to accelerate that, and having the ability to modify prototypes on the fly is one way to do that. And so just to look at those steps, conceive. So this often starts with a sketch where we'll start to draw things out. This is in one, they were designing a restaurant here in one of my workshops. Create. We start putting things together. We talked before about this allowing for collaboration and different areas there. Learn. We test things out and we start to learn what works and what doesn't work. And I just want to pause on the idea of learning. The key thing is you want to get user feedback. Dislikes teach more than likes. It's because they mean our original ideas were not correct. If we did a prototype and everybody said they love it, it just means we were right on all points. If we want to learn, we really want to find things that we didn't know. And so understanding what doesn't work is, in some sense, more important than what does work because it means that we're learning. Observe as well as ask. Look for pain points. Look for incongruities. Look for inconsistencies. And try as many combinations or tries as time allows. Learn as much as you can. That's the whole process of prototyping. And finally, refine your idea, go back to the drawing board literally, and try to recreate a new idea that you can then move forward on. Document what you've learned. What should or could you change? Often you have many ideas. One of the things that is often necessary, and you may have seen this in the IDEO examples, is that you need to reduce your number of ideas that come back. So voting is one way to do that, have everyone vote on features. You could also use the problem owner. We talked about Synectics to decide which of the features you want to go with. And you want to try to reduce your ideas. As you saw once again in the idea of shopping cart, they built several prototypes and then reduced the best ideas into one. And only once a prototype achieves all of its value, once a prototype achieves all of the value intended, you want to move on. Really, it's about ideas. It's not something we necessarily need to keep. So the progression for prototyping is you start with an idea in your head, sketch or do a quick draft, build a prototype, learn, refine and recreate the prototypes. When the idea solidifies, move to alpha and beta testing. For those of you that work in product development, alpha and beta testing are known stages of the product development process. Alpha testing is when your product is still a prototype, but it's a prototype for users to actually use. And it's intended, for example, when we looked at Target, where they actually had the products in a bag and a user could use it. The beta is the near final product, and it's not only about testing your product, but also that your capabilities for building the product. So often a beta testing might ship to thousands of people to see how it works, to see how the shipping goes, how the receiving goes. People can learn how to use it, understand the instructions, those kind of things. The prototyping we're talking about is well before all of this and is really about learning, where in product development, which we'll learn in a later lecture, alpha testing and beta testing are really about proving out the process. It's not about generating the ideas. So prototyping summary. Prototyping is to explore ideas, generate new ideas, share ideas, collaborate, test ideas, and the best prototype is the one that leads to the quickest learning. The key is a minimal viable prototype, the simplest we can possibly build. And prototyping is a continual process which creates, tests, and refines, and then repeats. And that's it for prototyping. I hope I've shared with you some insights into why we prototype, how we prototype, and some of the process that we go through in prototyping. I'll now open up for questions. I do see we have one of the questions. At what point does your prototype become a minimal viable product? And I think that's a great question. The separation between innovation prototyping and product really goes between when you stop making something for testing ideas and you start making it to be a product to be sold. And I think that's really where you go into a minimal viable prototype from a physical standpoint. From a business standpoint, when you're able to show that the prototype is capturing the value that you intended, and that value is sufficient for you to capitalize on, meaning you can make money on it, you can produce it, that's when I think you really have a minimal viable product out of your minimal viable prototype. And I think Grandma's Remote's a great example that teaches us ideas, but it's not something that we could use. But from that, I think one of the takeaways would be a minimal viable product for Grandma would be a remote that has fewer buttons. And I know for all of us with a universal remote, we'd really like to have it. If any of you have used Roku, R-O-K-U, this is a company that makes streaming devices in the US. And one of the unique features about the remote is it has about half the number of buttons as a typical remote does. I'll open up if there's any more questions out there. And I'll just give a few minutes to see if there's any more questions, and then we can talk about next our next lecture. Just pulling up the, I think I'll just pull up the, here we go. Perfect. Let me just share my screen. So today we just completed prototyping. Our next webinar will be in 2 weeks, will be on futuring, and I think this is going to be a really interesting lecture on how do we predict the future, if you will, but how do we take the ideas we have and look at what they might be in 5 or 10 years. And this is really great for developing company strategy. It's also really good for looking in a long-term strategy and where we're headed. And we're going to use some tools that help you understand that, you know, looking at where the future is both about you envisioning and creating a future from the ideas you have today, but then also understanding some of the constraints so that we're not based in some reality in what we're going to do. Great, so I look forward to joining me for that. And then we'll have product development for innovators after that. And their final one will be on innovation canvases, business model canvases, ecosystem canvases, and sort of how we pull this all together into an innovation strategy. I want to thank everybody for their time. I'll stay on for a few more minutes. If anybody has any questions, throw them in the chat. And we've got a couple in the Q&A. People use the Q&A. Great. One of the questions, any differences when prototyping services? Actually, no. I think the the mistake people make is they think about prototyping is about making a device or something. So for services, the way we look at that is we want to prototype the flow. So PowerPoint's a great way, a storyboard where we draw out the services we're doing, what is the time sequence of those steps. And then we can take an image of each one of those steps and describe it, and then try to understand, are there missing steps? So for instance, in providing services, one of the key things that we'll see is oftentimes there's a pain point where we'll go from one step of the process to the next step of the process. And we'll suddenly realize that the step between the two, people look at that and they don't understand how we made that transition, or we need an intermediate step, or maybe we can skip a step. So it's just, we don't make a product. We tend to do storyboards. We do time sequences, cartoon sketches to kind of show each part of the process. And then when we test it, what we do for services is we actually walk through the service as it's delivered and try to understand and observe how that works. Great. Looks like we've wrapped up most of the questions that we have for today. I appreciate everyone's attention, and I really look forward to seeing everybody in 2 weeks. Thank you very much. Take care.